Time, the most common and fundamental aspect of reality. Everything that exists goes through time without a choice.
Nobody, not even the greatest scientists, can perfectly decode the mystery that is time. But some very fascinating ideas have emerged while trying to understand it. Hey, I'm Kian, and today I'm going to explore a bit about time. Now, let's start by looking at time as a dimension, which makes sense.
In the three-dimensional world, you can define a position such as your house or at the movie theater, but you can't make complete sense without adding another dimension, time. You also have to mention the time, like I was in my house at 4:30 and went to the theater at 5:30.
Another similarity is that time also bends near extremely massive objects.
It slows down near gravity as the fabric of space-time is bent near massive objects. Now, imagining space-time is quite hard. After thinking about the three dimensions of space itself, where will you add a fourth dimension, time, in order to make the four-dimensional fabric of space-time?
The point is, extra dimensions are beyond human thinking. They are unimaginable. It's as good as trying to explain the color red to a colorblind person. You can try as hard as you want and be as descriptive as you want, but they can never accurately get it, right?
Anyways, there are some aspects of time that don't completely agree with it being a dimension. Like, it only moves in one direction, forward. In a spatial dimension, you can go forward, backward, left, right, etc. But it's not the same with time. Similarly, you can place an object somewhere, and if you don't move it at all, its placement will be the same, with no change. But it has been subject to time. It has inevitably moved forward in the arrow of time.
But wait, let's dwell deeper into the arrow of time.
We don't yet know why the arrow points only in one direction, so at least let's try to define it by associating it with something else more definite. Entropy. Basically, net energy in a system tends to disperse, order tends towards disorder. The term entropy is used to describe this dispersion or degrading of energy. So, we can say that entropy increases with time. If we assume that the universe plays along with the rules of the second law of thermodynamics, entropy, then we can associate time with it.
This increase in entropy is called the arrow of time. And the certain set in which we are observing this is the universe itself. We have observed and realized that the universe is expanding. It is tending towards more disorder as the arrow of time moves ahead.
Now, building on this logic, we can say that any time before the current one, the entropy was lesser than what it is right now. And similarly, the time even before that would have even lower entropy. And so on till we get to a point where the universe is an incredibly small and immensely hot point. The Big Bang.
Time is indeed very mysterious, and it can also do weird things such as bend and dilate.
You see, Einstein proved that the faster you go, the slower time goes for you. To give an example, if you have a twin and you board a rocket that is going to go extremely fast, when you return, you would be way younger than your twin, as time slowed down for you. But how did he prove this, and what does this imply? I'll explore these topics in my next video. Thank you for watching.